Thank you PCBWay for sponsoring this video. So you're looking to get into 3D printing. Did you see some cool models you want for yourself? I've been printing about 8 years now, starting with a printer so old that it didn't even have auto leveling and was a truly manual process. I want to share with you some modern 3D printers, some tips I learned along the way, and how to use multicolor support. I have a few models I've printed here that we're going to step through together. Technology has matured so much, I don't even get to share my pain with you from the good old days. Now let's start with the printers. So you started shopping for printers, and you probably noticed mostly two common types. A Cartesian printer or bed slinger from here on out, generally found in the entry-level prices, and if you spend a little more, you saw an enclosed Core XY printer. You'll find both types in all price points, but generally the bed slingers are less expensive, but it depends on the features. I want to talk about the features you also need to look for and may not be obvious. Most importantly, does the printer have auto leveling? I used to have an Ender 3 version 1 without auto leveling, and using a piece of paper to manually level was awful. Auto leveling is available on most printers nowadays, even in cheaper categories, so really only relevant if you're shopping for the cheapest printer possible. But it's a must-have since your goal is to spend more time printing than troubleshooting. I spend more time with that early Ender messing with the printer than actually printing, plus auto leveling is the biggest feature to elevate your print quality. If your printer advertises auto leveling, then you'll consistently get decent prints if you keep up on the maintenance. The next feature I suggest you look for is a built-in camera, or one you can add on. You'll get cool videos for YouTube, but more importantly, combining a second feature, AI detection. Generally reserved for more expensive printers and not required, but if a print fails, then using the camera on the printer can look for a failed print, typically in the form of spaghetti. This would stop the print, save you money compared to it continuing to spit out filament who knows where. Just about all the printers now come with a filament runout sensor, but if you don't have one, then you need to be absolutely sure you have enough filament for your print. If you run out of filament, and the sensor would stop your print and allow you to refill it with another same type filament. But without that sensor, it will continue to heat up, may ruin your nozzle, and continue printing, although there's no filament. The other feature I consider important, but are universal, does this printer have nozzle options? For example, the Anycubic Cobra 3 Max I have currently does not have model options. It's 0.4mm only. The 0.4mm nozzle comes with every printer, and it's a great all-rounder. The 0.2mm is great for detailed miniatures, but takes a long time to print. While the 0.6 and 0.8mm I have in the P1S will print fast, but has thick layers, and it's great for iterating designs. You should also know how fast a printer can print. Generally, you will be limited by the filament and slicer settings, but a fast printer will be over-engineered in stiffness and reliability. The most common inexpensive printer you'll find are these bed slingers. Examples of a bed slinger would be the popular Bamboo A1, A1 Mini here, Creality Ender 3, and Anycubic Cobra that I have a review for. This is where the print bed moves back and forth while the print head moves side to side and up. This is generally a simple printer, and with simple comes lower cost, less to break and troubleshoot. For example, Core XY printers have more motors and belts to achieve their advantages, which you don't have here. On the other hand, these are generally slower printers. Modern bed slingers advertise Core XY speeds, but in my experience, don't quite meet that marketing. Because the printer is moving the whole bed, the larger the bed is, the more mass and inertia is being thrown around. This results in more vibration, so you need a sturdy table. These printers also take up more space. While the frame has its own footprint, you need room in front and behind of that printer for the bed to move fully in each direction. For example, my Cobra 3 Max behind the camera has a frame length of 25 inches, but actually requires 39 inches of space. This A1 Mini here has a frame length of 13 inches, but requires 16 inches of space so the bed can move fully. Now, Core XY printers have a print head at the top that moves with the rails and belts while the bed lowers to complete your print. Common examples of these printers are the Bamboo P1 here, there's an X1, and vendors out there have their own like Creality and Anycubic. Generally, these printers are also enclosed, which means you can start printing ABS right away, which we'll cover in a minute. These are faster printers because instead of moving the whole bed, it's just moving the print head, which weighs far less. To get the speed and quality, a good Core XY printer will have 2 motors per axis. These are more compact because you don't need to move the bed back and forth, but they are also generally more expensive. More motors, belts, enclosure, multiple drive screws, the costs add up. There are lots of different filaments out there. Without counting, there are dozen plus materials with variants within each material. So let's focus on the most common filament types and touch on some of the cool specialty filaments, which you're not going to buy until you know your printer inside and out, right? The 3 common filaments I want to show you are PLA, polylactic acid, PETG, and ABS. I recommend starting with PLA if you're truly a novice. PLA is relatively cheap, common around $10 to $12 a kilo on sale or in bulk, although tariffs, if you're in the US, probably already put this video out of date. It's more accurate, resulting in nice smooth prints, and shelf stable at about 1 to 2 years when stored in a cool, dry bag. PLA isn't heat resistant though, so if you need something that can handle higher temperatures, then you need to move on to PETG. While PLA is stiff, it also makes it brittle. It doesn't give in to pressure like PETG would, meaning it's stiff until it isn't. Then it shatters. PLA is best for calibrating printers, prints that require accuracy and better tolerances, easy on the wallet, and generally found in cosmetic prints like cosplay or props. PLA also has a ton of variants, like you may have seen PLA Plus or Tough PLA. This is a mix of material, mostly PLA, but it also increases the heat resistance and it's more durable. Lightweight PLA is PLA, but the mix makes it lighter than standard PLA. This isn't commonly used, but you will be using it if you're into drones, RC aircraft, or maybe prosthetics. You'll also commonly find what is called silk PLA. This finishes with a shiny or glossy look to really add class to whatever you're printing. You'll also find color mixed rolls of filament for that rainbow look. Never seen it on the shelf. Apparently there is conductive PLA, a mix of graphene that you can run low volt across your 3D print. Be very careful of the hazards and loads. That's up to you to research, but I thought that was super cool. Another popular filament you'll hear about is PETG. This filament doesn't produce as much detail as PLA, but it is a great functional print filament to use. It's more resistant to warping, doesn't produce an odor while printing like ABS, is temperature resistant and even UV resistant if you need something outdoors. The next most common type of filament is ABS. This is what many of the toys on the shelf at say your local toy store are made of. It is by far the most durable when compared to PLA and PETG, and the most temperature resistant. However, this does require an enclosure because the print needs to stay warm for the duration of the process, otherwise it'll warp as it cools down. It also produces a toxic odor, so you need to vent your space, or there are filters you can install to help. Finally, a few filaments that I think are super cool, but you shouldn't buy as a beginner. Many of these filaments come with a variation where they are fiber reinforced to increase durability by adding literally little fibers into the filament. These fibers can also increase tensile strength, ability to bend, and how much impact they can take. However, they are harsh on nozzles, and your 0.4mm brass nozzle won't cut it. These filaments are also expensive, so you're going to want to use them sparingly. The other cool material is TPU. This can squish and is flexible in a way no other filament is. Think of an RC truck, and that TPU would be used for printing the soft rubbery tires. I would still stick with rubber, but you get the idea of how squishy it is. My favorite specialty filament is a support-only filament that dissolves in water. Yes, you can submerge your print in water for a few hours and the supports melt away, which is great for supporting areas inside a model that you normally cannot remove supports from. I have a video on that. I'm going to link it somewhere. You should check it out. It was amazing. If you find a model you like in the next section, but don't have your printer set up, out of commission, or don't want to bother with 3D printing anymore, you can hand that work over to PCBWay. Upload your model you want, select quantity, material, color. Not sure what to pick? You can use their assistant to help you get exactly what you want. With a quick turnaround time, you can get your model in just a few days with a professional level finish. Not only can they 3D print, but they have CNC machining, custom PCBs, PCB assembly, and if your project needs it too, use my link in the description below for $5 off your first order. All right, before we download our slicing software, let's first find a model we can import. There are branded websites that target a certain manufacturer, but I want to introduce you to Thingiverse, and who I consider the original model site, at least in my experience. Thingiverse also only really supplies STL files, which is a file that defines the shape of a model. As we get into these other websites, they may offer a 3MF file. While I showed a bit of 3MF file in my Creative Cloud video, linked somewhere, it's essentially a zip file that contains project settings. This can be print settings like layer heights and info patterns, predefined support structures, and if you have a multi-material printer, then it could also have a list of filaments and settings that the author used. We're going to focus on MakerWorld since I enjoy using my Bamboo printers, but also every brand has their own website, which I encourage you to check out, especially since you can be more assured that the model you find has a print profile in the 3MF file you can download. I'm partial to Minecraft and their animals, so I want to print a larger chicken. Once we find one we like, there are even more options. Top to bottom, let's start with the print profile. I have a P1S I'm going to use to print and an A1 Mini, but only my P1 here has the AMS. So I'm going to click on the P1S here. Underneath, there are various print profiles that the author and community have provided. The author or designer is clearly marked, so the other profiles underneath are community provided. Once you found a model you like, you can typically just open it with your preferred slicer, but for now we don't have one, so you can download the 3MF or STL file. I'm going to be using the 3MF because I know I'm getting my P1S print profile and the author's print settings. Again, you can download the STL file if you just want the raw model with no type of profile. Great, we found a model, but now we need a way to get that model into the printer to actually print. Well, the good news is you probably downloaded a slicer as part of the settings for your own printer, but we're going to cover the basics anyway. I keep saying slicer, but what am I really talking about? Pretend I'm jamming this Benchy into a meat slicer. You'd find it like a deli counter in a grocery store. What would happen if this was made of ham? Well, it sliced it into thin layers, and underneath it would stack to rebuild the model in each layer. That analogy sounded better in writing, but it's not far from what's actually happening. Your slicer application is taking your model and creating G-code, a language understood by your printer, that controls everything. It will define where the extruder starts, ends, the path it follows for each layer, then the same information for the second layer, which will be slightly different from the first. This can go for hundreds, maybe thousands of layers, hence the meat slicer analogy. Anyway, go to the website for your printer and download what they recommend. And since I like my Bamboos, I downloaded Bamboo Studio. Before we print our chicken, let's print a classic Benchy, which is and was a classic benchmark for tricky 3D printing. The first page is some simple interaction with MakerWorld and some recently opened files, but I want you to click on Prepare. On the left, we have our current selected printer, just in case you have multiple, and the type of plate we're using. It's okay to leave it on the default, since you don't just accidentally upgrade your plate without spending additional money. I currently have a larger 0.6mm nozzle, which I do have more information in another video linked here. So yours says 0.4mm, while mine is currently 0.6. Then we see our current filaments in my AMS, but if you don't have one, you'll only see the single filament on a roll. Underneath the filaments is a nozzle profile, which yours says 0.2mm, while mine says 0.3 because again of my larger nozzle. Just keep this at 0.2mm standard. There are a lot of options here we can change, and we didn't even toggle advanced mode. But the ones I want you to be aware of is layer height on the quality tab. Don't change this, but you can increase the layer height for faster, less detailed prints, or lower it for slower but smoother and more detailed prints. The Strength tab has sparse infill options, which is the type and amount of filament used inside the model to strengthen it. Higher is more better. Straight to 100% if you want a solid block or whatever you're printing, which may be useful if you want some heft. If you have overhangs around 45 degrees or greater, then you want supports. Normal supports create a block-like structure to support your actual model, while trees grow to support your model. I personally prefer trees, but you do you. Finally, on the Others tab, if you're having issues with the model adhering to the bed, you could come in here and add a skirt or brim that increases the first layer footprint, improving how well it holds onto the build plate. Right, now on to Benchy. Bamboo includes some test models, and Benchy is one of them. Right-click on the build plate, add primitive, click 3D Benchy. If you made any change to the default settings like supports, then undo these. When you're happy, click on Slice Plate, and soon we're presented with some print information, details about walls, infill, etc. But really, I just want the print time. If we zoom way in, we can see those layers we're slicing. Orange is an outer wall, yellow is an inner wall, blue is the bottom, and lighter blue is a bridge because technically it is suspended midair like a bridge. Also notice we're on the Preview tab because the next step is to click Print Plate. Once again, we see how long and how much filament it will take. We have our P1S selected along with PEI plate. This is another chance to change our filament used for a single color print. We can also select a time lapse if you want one. Always set bed leveling to on. Send it, and we move to the Devices tab. Here we have real-time information about our printer and can turn on the camera to watch. Benchy had some issues in the end, but I wanted chicken, so back to Maker World. And click Open in Bamboo Studio. There is a lot going on here for someone just starting out, but first of all, this model is split into 2 plates. You can print one plate after another is finished, or you can send one plate to printer A, second plate to printer B, which we're about to do. The circles around the model part are new, and that's because the author had this printed by object to reduce flushing and waste that the printer causes by changing colors. Prints can look great switching colors, but this separate object approach is more efficient. We're getting this error that waddle.object is too close to the others, so let's look at the objects to find it. Yeah, there's no way we can arrange this to fit the plate, and print profiles are supposed to work out of the box. Since we have 2 plates and I don't want to waste red on a hat ribbon, this plate will be only yellow, so let's move the chicken legs over and we can now rearrange our first plate so there's no bumping into each other. Finally, let's map our AMS and overwrite the author's AMS settings. I'm worried about supports, but if we need them, we'll also get an error message saying we absolutely should have them. So let's slice it and no warning. The nice thing about 2 printers is that you can print this twice as fast, sort of. This half is about 3 hours, so let's print it with a time lapse. In troubleshooting, we'll talk about this layer shift that happened, but I went ahead and tried it again on its own. Back to the Prepare tab, select the second plate, then select the A1 Mini I have here, slice the plate, and this half will take about 90 minutes. Send it to the A1 Mini and wait. Now that it's done, get some glue and assemble your own Minecraft chicken. I'll let you find a zombie to add for your own Minecraft chicken jockey. The other common print you'll do with an AMS or an AMS-like system is printing multiple colors simultaneously. This is actually going to work just like the chicken body, except all your colored objects are within the model, or painted, which is relatively new. Changing filament every layer will produce a ton of waste, and I recommend you check out my P1S review where I make a 4-color Benchy to really show how much filament is wasted, but the process to print is the same. I like Bamboo because it's like the Apple of 3D printers. It just works, and it just works well. They didn't sponsor this video, and the community generally seems to agree. Any printer can get you your perfect print, but requires some tinkering. I had to do a little with my Anycubic Cobra 3 Max in a review video, but I learned the hard way with my Ender 3 V1 in 2017. It was a very manual process. Some of the common issues I've become painfully aware of is how critical a good first layer is. If you have a bad first layer, first return all custom settings to default. If you don't have auto leveling, now is the time to do so. Take a standard sheet of paper and move that print head around the bed. In every corner, raise and lower the print bed so that the extruder nozzle just slightly drags on the paper without destroying it. Do the loop 2 to 3 times because minor changes in each corner makes minor changes in all corners, but eventually it evens out. If you still have first layer problems, make sure you then clean the print bed with gentle soap and water with a wipe down and a little isopropyl alcohol. If you have a model with layer shift, like this one, make sure it wasn't sticking to the print bed. If it came loose, then go wash that plate again so it sticks, or invest in glue made for printer beds. If you continue to have these issues, slow down your print, tighten your belts if you can, and maybe the belts are jumping teeth. Then, look into adding a skirt or brim in the slicer to help it adhere to the print bed. Under extruding and over extruding can make models look ugly and crumble just by picking them up. Under extrusion will put out less filament than the G-code wants to. I first suggest you clean your nozzle to make sure there's no kind of buildup or clog restricting the flow. In my Ender 3 days, I found the extruder gear teeth were worn, so it couldn't push as much filament as needed, so check those too. Over extrusion is when too much filament's coming out and your print looks like they just finished a fat Thanksgiving dinner. If you print with abrasive filaments, then it's probably worn the nozzle down and it's a very slightly wider than it should be, meaning more filament comes out and should be replaced. This is an amazing hobby with literally endless possibilities once you start creating your own models. Honestly, you can love this hobby printing models that others make since there is over 10 years worth of uploads and some of the most obscure parts that you thought only you needed. Since you made it this far, check out my reviews of the P1S, the A1 Mini, EZ3 K9, and Cobra 3 Max. I have videos on changing your nozzle, the dissolving support filament too. I'm always looking for cool ideas.